In this lesson, we're going to solve exponential equations. And an exponential equation, if you look down here at example 1, is in the form where you have numerical bases, but you'll have variable exponents. And so we're first going to start with the idea that if you have an equation where b to the m equals b to the n, so you have same bases and you have some expression for the variables, then logically m would have to equal n. So our goal for this type of equation is to see if we can write each side of the equation using the same base. Once we do that, we're going to set the exponents equal to each other and solve. So let's start with example 1a, and we look at 2 and 16 and we see that we can write both of those with a base of 2. So we have 2 to the 3x minus 8 equals 2 to the 4th. Now we'll set the exponents equal to each other. Adding 8 to each side, we get 3x equals 12. Dividing each side by 3, we get x equals 4. And now I think it's a really good idea to check your answer, so we'll substitute 4 back in for x. Evaluating 2 to the 12 minus 8 is the same thing as 2 to the 4th, and 2 to the 4th equals 16, so we solved that correctly. Ask yourself, what base would I use if I started off with a 27 and a 9? We're going to use a base of 3, so we're going to write that as 3 cubed to the x plus 3 equals 3 squared to the x minus 1. I'm going to now get 3 to the 3x plus 9, remember to distribute, equals 3 to the 2x minus 2, again distributing that 2. When you raise a power to a power, you've got to multiply. Now I set my exponents equal to each other and solve the resulting equation. Subtracting 2x from each side gives me x on the left-hand side, and subtracting 9 from each side gives me negative 11. Okay? And so see for yourself that if you plug in negative 11 in for x, that you do get the same exact answer on each side. So I'm going to check this. I'm going to check it right here. We've got 27 to the negative 11 plus 3 equals 9 to the negative 11 minus 1. So 27 to the negative 8 equals 9 to the negative 12. This ends up being 3 cubed to the negative 8, or 3 to the negative 24. This is 3 squared to the negative 12, which is also 3 to the negative 24. And so that also works. So what I'd like you to do right now is pause the video, try these two problems, and then start the video up again to check your answer. Okay. So for 5 to the 3x minus 6 equals 125, our common base is 5. And 5 to the third power is equal to 125. I'll set my exponents equal to each other and solve. Adding 6 to each side gives me 9. Dividing each side by 3 gives me 3. Can check our answer by plugging that in. I'm going to do this mentally. When I plug 3 in, I get 3 times 3 is 9, minus 6 is 3, and 5 cubed is 125. So we can be confident in our answer. Number 2, the common base is a 2, so 8 is equal to 2 cubed. We'll raise that to the x plus 2. 4 is equal to 2 squared. We'll raise that to the x minus 3. And raising a power to a power, we multiply and have to remember to distribute. Be 2 to the 2x minus 6. Set our exponents equal to each other and solve. Subtracting 2x from each side gives me x. Subtracting 6 from each side will give us negative 12. If we plug that in, we check that. Let's check that, do that one out. I think that's a little bit harder to do in our head. Let's do this right in the middle. So we've got going to have 8 to the negative 12 plus 2 equals 4 to the negative 12 plus, minus 3. So 8 to the negative 10 should equal 4 to the negative 15. 8 is the same thing as 2 cubed to the negative 10, and 4 is the same thing as 2 squared to the negative 15. We end up having 2 to the negative 30 equals 2 to the negative 30, and so we can see that that worked.